Welcome to today's session on the demonstration on Google Earth Engine for flood hazard studies. Before I go into the actual demonstration that is on the GE, I'll just like to have some background before going further. As you all know, that flood hazard is a very, very prominent hazard which impacts globally, throughout the region. This hazard has a prominent role in impacting the societies, whether economy or the life or the mortality. And also the number of events are much higher compared to any other hazard, which this particular slide shows. This is a database from the EMDAT, which shows the number of events that are on the darker blue circle are far higher than the last 1 decade average. And these events, flood hazard events, are not increasing, but their severity is also increasing. And every year we are facing a very unique type of flood event. Whether you can just recall previous some of the events, whether Kerala event of 2018, Chennai floods of 2015, or this year 2019 floods of Bihar, or this year now Chennai or Tamil Nadu and Andhra Pradesh or Tirupati, in fact, is facing heavy rains, and there are a lot of casualties and due to this extreme rainfall event and the subsequent flooding. So with this background, remote sensing has a very potential role, in flood hazard studies, whether it is before the flood starts or during the flood hazard flood event or post flood. In all the management cycle of flood hazard, remote sensing has a very important role to play, and this is because satellite gives us a synoptic coverage. It gives us an overview of a large inaccessible areas. We can compare the pre and post flooded areas, and we can also, since these satellites are orbiting around the Earth, we can have a temporal monitoring. After every 5 days or 2 days or 10 days, these satellites keep on coming revisiting, and we can compare how the situation was there few days back and now. And with the constellation of number of satellites from different agencies, we can even have a single day monitoring kind of situation through like platforms like International Charter when they are activated. So we have a number of satellites, almost 64 to 65 constellation of satellites monitoring one place. So we have a frequent coverage over the hazard areas. And these satellites also have all weather conditions. They can image the flood areas, whether in the cloudy conditions or in the clear conditions, or even in the day and night light conditions. So that is what is the advantage, especially with the microwave, because the flood timing is when there are a lot of clouds and the weather is not so suitable for optical imaging, because optical sensors due to their smaller wavelengths cannot penetrate the clouds, and these microwave sensors due to their higher wavelengths, they can penetrate the cloud cover and and image the earth or the flood conditions on the ground. And most important, one more factor is there, that these satellites are not prone to damage, unlike the instruments like the gaze stations that we have on the ground and that we conventionally used to rely, because once we get data from these gaze stations, then we know when we do our modeling efforts or we have some kind of rating curves. But in certain circumstances, these gaze stations itself may be washed away, and we may have no record of the event, or the magnitude of the event. But since these satellites are rotating, at a certain height, they are not vulnerable to such kind of damages. And moreover, we have very another kind of instruments, satellite altimetry. Also, there is one of the that has a potential of inland monitoring, and we have a number of virtual gauge stations, that can give us the gauge height from the satellites itself. And so these satellites, because of there are so many so many features, have today become an important part of flood hazard monitoring. And globally, by all agencies or all people who are working in the operational environment of flood hazard monitoring or flood hazard mitigations, are now using these satellites for having information. And the Sendai framework for disaster risk reduction also, gives a lot of weightage to the spatial information, and especially that is obtained through remote sensing or geospatial technologies. Now, coming to the remote sensing of the flood inundation, if we go from today's lecture, I'll be focusing only on the optical part, not on the microwave part. Microwave has a different aspect of fundamental of mapping the water, and optical has a different kind of. We will basically deal with optical remote sensing, and the case study will be also on the optical images. So before we go into the practical, I just want to tell you the background, that how it is done, what are the guiding, factors. So water typically looks blue or blue-green due to stronger reflectance at shorter wavelengths, and darker if viewed at red or near infrared wavelengths. So water, if you see the curve of water, there is stronger reflectance at the blue and the green, wavelengths. And as we go further towards red or near infrared, there is strong absorbance, and the water gets completely absorbed at these, as at beyond, see, 0.78, 0.7 to 0.8. If you see, the water is getting strongly absorbed. So water absorbs most of the energy in near infrared and middle infrared wavelengths, and therefore it appears dark in tone. So if we see the water, especially in these bands, so we will find sharp, or dark black tone in these areas. And whereas if we compare with the vegetated areas or the all the other adjoining areas which are not flooded, and if they are covered with agriculture or vegetation and soil, they have a higher reflectance. Vegetation has a contrasting behavior once it comes to NIR. Vegetation is strongly reflected, whereas the water is strongly absorbed. So this gives us a clear differentiation, once we discriminate the land and the water regions. And if the water is turbid water increases the reflectance in the red end of the spectrum, and therefore the water appears to be in brownish appearance. So these are some of the graphs, again trying to tell you how the clear water, and in turbid waters, because the water is agitated, so the reflectance increases. It has a higher reflectance compared to the clear water. So the trend is almost similar, but there are other factors also which which affect the reflectance of the water. They are the depth of water, materials that are present within the water, and the surface roughness of the water. Turbid water, because it is turbid, it has a lot of sediments, so it increases its reflectance. The shallow and deep waters, which are clear, the shallow and deep waters, clear and turbid waters, so they all will appear differently. The water which is calm and deep will be more bluish in tone as compared to the shallow and the turbid waters. So these we can differentiate because of their tone, which is there due to the variation in the spectral reflectance. This is an example of what I was just discussing. These are 4 different bands, and from the LISTRI sensor, so set 2 data. which shows you same feature. You can, if you are familiar with the shape of the river, anyone can point out that this is a meandering or kind of river, but this is in the green band, this is in the red band, this is the NIR band, and this is the shortwave infrared band. So if in all bands we see at green and red, it is a higher reflectance water, and therefore it appears to be brighter, whereas compared to the NIR and the shortwave infrared, where this water gets completely absorbed, and therefore it appears darker. And because of this only, we are able to discriminate between the land and the water. And if you see on this part, this tributary is not at all visible in the green and the red bands, but once we come to the NIR and sphere bands, so it picks up. This water is very clearly picked up, and this tributary is very clearly picked up. And that is what, because from this graph we have seen that at these wavelengths, at NIR and shortwave infrared, the water gets completely absorbed, and therefore it appears in a darker, much darker tone, and therefore it helps us to delineate the land and water. This is one more example from the Sentinel-2 green and the sphere band. In this green band, this is the river, but if you are not aware of the area, you may have a little difficulty in identifying the water or the areas with moisture or the river pattern. But once you go to the sphere bands, the river flow is very clear, and the water and those areas which are affected by the rain or the flooding are more clearer as compared to the green band. So green has a higher reflectance, stronger reflectance, and whereas this band has a stronger absorbance. So that is what is highlighted in that particular slide. And once we create false color composite, FCC, we may get different kind of tones, and these tones, as earlier discussed, they vary depending upon the nature of the water body, whether it is deep, the water is calm, or it is like here, if you can see the tone is different. It's the deep water, and if it is freshly flooded, you may have a different kind of tone, or if the flooding is a little older, you may have a different kind of tone, and if the flooding is on a recession part, you may have a different kind of tone. So from the tone, this reflectance, we may find out different kind of the flooding environments. And this is one slide which shows you the potential. Earlier I told you that these satellites, why they are used, because they have a large swath, and they give us a synoptic view. And this is one of the satellite modes, Terra and Aqua, which are the two passes in the morning and one in the afternoon. Terra in the morning and Aqua in the afternoon. And swath is more than 2,000 kilometers. So you may have a synoptic view, which is not possible from the single eye or human eye. It is not possible because this eye is on the space. So we have a larger view, of the same area. So that is why they are helpful. One more example I told you, because these satellites are continuously observing the area. So you may have a temporal monitoring. You may monitor in the morning. This is the event that was monitored from a combination of different satellites. Like in the morning, 6 hours reset. In the afternoon, again we had reset, and again we had radar set. So you can continuously morning, afternoon, next morning, you can monitor the situation, how the water is progressing. Or in this case, there was no water, and the next morning again it gets flooded. So you can monitor such kind of events and have a map of the progression, recession, or the persistence of the flood water, and they are very useful for utilizing your resources in times of crisis. These satellites, because of their resolution, also give us different levels of information based upon their resolution. Very high resolution images help you to even discriminate the settlements that are flooded, or the embankments that get breached up, or the trees or the maroon villages, or you can also identify the damaged infrastructure. Or because these satellites are continuously monitoring the area, over the time, you may also be in a position to see the flood duration, how many days the water is persisting in an area, because this will help you to because if the water stagnates for a particular more than a particular time, let's say more than 7 days or 10 days, the crop will start wilting. So you may have a problem of all that kind of, or you may have a spread of epidemic diseases. So you need to have a focused areas where the flood duration is now extending, or it is persisting. Once you have this flood hazard layers, you can integrate with the land use, villages, roads, and to find out the crop or area submerged or the villages marooned. So this kind of also information can be derived, but in any case, the flood hazard remains a very important source of information. Once you have flood hazard, you can integrate with your GIS database to extract all those information, but you require a flood hazard layer. And once you have a flood hazard layer, you can also go for flood hazard zonation. You can use different techniques. You may integrate with it with number of parameters. You can have your own weightages, and you can derive a flood hazard zonation. This is one of the examples where we have used this data for flood hazard zonation for the state of Bihar by using numerous old last 2 decades of satellite images and the flood waves from the Center Water Commission, and and the land use. We have generated the flood frequency, how many times the area gets impacted by the flood. So now coming to today's exercise, that was the background, just showing some examples how the satellites can be useful and how they play a role, and what is the background which helps to delineate water in optical domain, optical spectrum. So now coming to there are various ways for delineating the water, or you may say the flood areas, and out of them there are numerous indices which have been developed, which help you to rapidly identify those your water spread or spread of flooding. And of those indices, one such indices is normalized difference water index. That is what we are going to use. So NDVI is used to monitor changes related to water content in water bodies. So NDWI uses a formula that is green minus NIR upon green plus NIR. Green, because to use this indices, you should have some background. So that initially I had showed you one slide which shows there is a higher reflectance of water in the green band, and there is a strong absorbance in the NIR band. So in the one it is higher, and one it is very low. So that is why we have we have subtracted both and taken ratio. So all the water is because it's the ratio you have values, all positive values coming for water. This indices was later modified also because of some mixing with the urban areas, and we had a modified NDWI. This also can be used, but today's example I shows NDWI. So this is NDWI, means we have used green minus, in this formula, green minus NIR. So if you see sentinel 2 bands, there are 12 bands in this. So if you see this band 3 is the green band and band 8 is the NIR band. Both are at a resolution of 10 meter. So we are subtracting green minus NIR upon green plus NIR. So this is just to show you these are the bands, how the Sentinel 2 has these bands. This is example. So this is example of Kerala. This is pre-flood Sentinel 2 data before the floods. This is during the floods. And this is the green band, and this is the NIR band that we are going to use from this green and NIR band. These are green and NIR bands. So if you have to do it conventionally, so you need to download all these data sets at your machine, and then you need to process them, and then you need to rectify those data sets. You process those data sets, and then you need to use all those RGIS or any commercial or QGIS software to get those bands, subtract those bands. Then you need to you run your formula, and then you need to classify those layers, and then you need to extract those layers. So this is a conventional way that this exercise also can be done. And finally you can have your own map, and you can convert it to a vector or a raster, whatever you want. So this way you can create your output. But what has happened by using by the emergence of this Google Earth engine, which gives us a cloud-based computing environment where you need not have your own you are not required to have your own software. you are not required to have much storage, and you also need not bother about where the satellite images are. You need not download any data set, neither the raster data set, neither the boundary of our area. So you only need to have a machine, and you need to have some kind of good internet connection so that your script can run. And you need not have any kind of scripting environment also in your machine. Nothing has to be downloaded. Only thing, you need to have a connection so that you can run your GE. So this provides the infrastructure optimized for parallel processing of the geospatial data. This GE has access to multiple kind of data sets. There is a volume of data sets from different satellites, whether you want Landsat, MODIS, Sentinel-1, Sentinel-2, rainfall, want temperature, pressure, population, any kind, even the administrative boundaries. All those are hosted in that particular GE, and it is a cloud-based environment. So you only need to have, it also provides APIs for JavaScript, application programming interface, and Python to enable researchers to perform. You can also perform your own analysis at a larger scale. Earlier, because these Sentinel-1 or Sentinel-1, especially these data sets are very large in volume, and if you start downloading, few scenes, your machine may get exhausted. One, in terms of space, and other, its memory also may not support you to run the entire process. But once it comes to GE environment, all these large scale, earlier you could do that analysis on a small region or a small one scene only, but now you can run on number of several scenes, and analysis can be run. So and there are extensive documentation is there. So it provides online integrated development environment IDE for rapid prototyping and visualization of complex spatial analysis using JavaScript API. So there are a number of data sets. Just to show you. So this is the interface, where you have the code editor, you have the script manager, API documentation, asset manager. Then you have an inspector that helps you to locate the pixels or the value on the map, and you have a interactive map display over here, and it is like a kind of you have a GIS field where you can zoom in, and you can pan the image, and there is a task manager which shows you what tasks you have put into operation, and there is a console output, which also tells you about any errors are there. So it shows you all that. So this has a number of functions. This GE has a number of functions, whether you require for raster or vector processing. Like image, for image you can have the band math, clip, you can mosaic, or you can do image collection. You can aggregate, you can filter, mosaic, sort, feature. If it is a feature class, you can have buffer, centroid, intersection, union, transform. Feature collection, you can have filter. So there, you can reduce the data by different processes. You can join, you can have machine learning, you can have a random forest classification or bias classification. You can have different projections. So over 1,000 data types and operators are there, and a number of other operators are coming. So from the GE, you can get an image. You need not have the image, or you need not go to the site and download the image. You can get an image. You can apply any algorithm on this to whatever you are interested, to an image. You can filter from thousands of images. You can filter whatever image you are interested, or if you're looking for cloud-free data or less cloud data, you can filter those images. You can map an algorithm over a collection. You can map throughout these images. You can use an algorithm. You can reduce a collection. You can just mosaic it, or you can have a aggregate output of these whatever input images are there, and whatever you are trying to get. Or you can compute and aggregate statistics. There are a number of images, but you want to have a mean, some kind of mean value for this particular pixel or something. You can have a aggregate statistics for your all data sets, whatever you have fetched. So there are many case studies. There are many studies which now are in the recent time have been published, or there are many freely available. Even scripts are available. You can just go on and search and get those scripts and try to run them in your machine. And you can also go through those publications are there where they tell you that this is now not only just for visualizing or seeing, but they are being run in most of the operational environments where they have used it for rapid and robust monitoring of flood events, or automated inundation mapping over large areas using Landsat and Google Earth Engine, identifying floods and flood affected paddy rice in Bangladesh. So for a country at a country level, you can run the entire operation in within no time. You can just run the entire script, and you can get the output for your entire country. Otherwise, running central one your operation for central one data for one scene itself takes a lot of time, and whereas here you are running for hundreds of images, and you are getting your output within no time. You're and there have been number of applications which have been developed from using GE. One such application is Global Service Water Explorer. You can just go to this site, and from the Google, you can just see Global Surface Water Explorer, where they have used from 1985 to 2019 or 20 now up to 2020 they have updated. This is an old picture, but now it is updated to 2020. So what they have done is they have accessed all the Landsat cloud-free scenes, and they have extracted the flooded areas and how the water has changed, or which areas remain under permanent water for last 20 years or 15 years. The kind of analysis is there, and they have created different kind of products like water occurrence change intensity, or water spread, and you can just go, and even the outputs can be downloaded also tile wise. These, if you are interested to have a particular tile of your area, that you can download also, and otherwise you can visualize in the platform. Just have your own assessment. So while running those scripts, it basically uses JavaScript. So they have certain kind of syntaxes or protocol where you have to write it. It is not simple writing, but once you start writing your script, you will understand that the scripts are written under a pair of parentheses or brackets. Whenever you end a statement, you have to end it with a semicolon. The strings are used to print out readable information. You can add layers. You can use map.add. There are different commands. Map.add layer, or you can also add images like e.image collection. Variables are stored. Values that make the code more readable. So you have it is sensitive. So just we will do it, and this is one of the recent papers that we also had. We had one study carried out for the state of Bihar for using the optical data as well as the SAR data. We had done some kind of analysis for the flood for the year 2019, and this study, we have used the Google Earth Engine, and these are the some of the figures, where this is a SAR data, but of course, so it is a pre-flood data. During flood, the change detection, it shows the areas where there was changes were observed. Then this is the Sentinel 2 data, and then we have used the NDWI, and we have extracted the flood areas, and this is the output of the from the SAR data, from the optical data. This cyan color is the flooded areas, and whereas this dark blue is the permanently the water bodies which are permanently over there. That is the main river stream. So this kind of analysis can be done, and this is one of the examples where we have done. Now we will go to the actual the Google Earth Engine. Basically, we will just go to the actual example that we have selected for today. So I just show you. This is one of the examples. So actually, this is what so to come, those who are new to this, so you need to have a account. You need to have a Gmail account first. You need to log in. Without logging in, you will not be able to access this. You need to have this particular site. You need to log in through code.earthengine.google.com. So this is our once you have this. So once you have this, so this your this window gets gets enabled, and you will see this. You need to have this particular access this site. and for accessing you need to have your own account, and you need to have your account in the Gmail. And once you access this, so this particular page will open, uh, the window which we were showing earlier. So here you can store your scripts, whatever script you are writing, you can store your scripts. You can have your docs, or already earlier, some of the scripts are already here. If you want to use them, like for date, or if you want to have some for geometry or for filtering, or you can have all those, those kind of are by default are available here. And you can have your own assets also. Assets means you can add your own study area, or you want to add some of your layers over here, so you can add all those which you want to use in the analysis. Suppose, say, if you are interested in using your own study area, you can add geotech data also. You can add shape files, you can add CSV files, you can add image collection, you can add a folder. So like if you want to add shape files, you can go to your source where your shape files are there, and you can select from that whichever files are there, like here. You can select those layers, and just open, and you can upload them. You can just, there is an option to upload here, so you can upload the data, and you can give some name to this particular whatever you are adding. By default it will take some name, but if you want to have your own name, you can write. Suppose, say, if you are saying study area or boundary, whatever you are saying, you can add it and upload. So it takes some time to get added over here, but that gets added into this particular that will get added into this over this particular assets here. So like you can see in the left corner, I have added many files like Bangladesh or India state, or whatever, wherever, Odisha or UP boundary, West Bengal boundary, Gujarat boundary, or whichever data I have used. So I have added. You can add those layers over here. So this is what I was, this is the main page where you can write your code. This is the page for writing the code, central window. And this is the interactive, window where you can pan, you can pan the images, right, left, and you can even zoom it. There is a plus cursor, or you can just hit on the push the central button of your mouse and just zoom it. You can zoom the wherever you are interested. You can zoom to that window, or to your results. If you are if you have run some operation, you can zoom into that. And and even if you are interested to draw your own study area, or if you want to have your own shape, if you don't have a boundary, suppose, say, you don't have any boundary, but you are interested only in a particular shape, you can also draw a rectangle and add it over here, or you can have a free shape. So you can do that, and whatever outputs from your script, whatever you have written the script, whatever come, they are displayed on this side, on the layer side. So in my case, these are the outputs that are generated. So they are getting added as a, you can just scroll them, and you can open one by one these layers on this window. And it just also gives you an option. See, like I have one boundary of the one district boundary, Alappuzha. We'll be doing this case study for Kerala. So Alappuzha is one district. So I can add the district boundary over here. So I can also, there is an option to, to have change the transparency. I can change the transparency. Suppose if I want to have, just see what is, if there are two layers, I can change the transparency of the layer to see the below. So it gives you the flexibility to change. Suppose in this, say, there is one image is there. So if I can just, decrease the transparency, so I can see below what is there below. So that is the one option is available to change the transparency. On the right side, you have over here, you have the inspector. So which gives you can click on the map to inspect the layers. You can click on the map and you can get a value over here, whatever script you have run, something will so by clicking on the image, and if nothing is there, even that it can give you, if you want to read the lat longs of that particular area, so it will give you on that particular area, whatever you have points, what is the lat long for that particular point where you have clicked. Suppose there is no script, so this inspector allows you to go through different your layers, and you can click on the layer, and whatever is the output, it will be visible here. So this console, any on this in this console, you can print the, if suppose if some dates you want to print the dates of the images that you have used. So all that will also can be printed over here. Suppose how many layers you have extracted, all that can be printed over here. And this task, if any outputs you want to generate and you want to store it, or you want to make it some outputs, so outputs can be displayed here. Whatever outputs you are think your script has generated, so those all gets added on this particular window. So this is the what, and there is one. See this. Once you write a script, it allows you to save. You can script write. You can save if there is no. You can save the script. Suppose if you're writing a new script. Suppose say I am writing new script, so I can save as. I can give a name to my script. Suppose say suppose say this is a test script. So I can save it as a test. You can add it, and it gets added to your project. Suppose say test one. I say okay. So if I go to my scripts, so somewhere this will come in down into under somewhere here, it will get as test one. So this save gets saved as test one. I can rename, I can change, I can delete, or whatever I want to do, I can do it. I can do it over here. I can also share the link. I can copy script path, and I can share the path of my script. 1 minute. So now what I'll show you, we were doing this example. I just show you now. Now I'll just show you. Suppose say this is the particular. Now in this case, since we are doing it for Kerala, so we want to, first we want to have those boundaries. For Kerala we want to have those, because we need to have the boundary of the state. So already boundaries are stored here within this. If you write FAOG, so these boundaries, see FAO, you should know this command. So like FAO GAUL, Global Administrative Unit Layers. Hello. हमसे वो क्लास so you can you can just search those layers. So there are, you can just click on those you can click on those layers. It will show you those boundaries. It will show you those it will show you those what these layers consist of, what is the table schema, terms of use, whether you can how it has to be acknowledged. It will all show you. So in our case, I have just used, I have, hello. What, now if I say, so in this case, so first my command is import the GUL administrative boundaries. So this is the, I have just shown you that if you go to type FAO, you will get the administrative boundaries, and the command, so I have used the I have used no level 2 boundaries I have used. So we have to define a variable. So or if you even if you have your own shapefile, like in this case, if I have my own shapefile, I can add my shapefile. See, here I have some boundaries, so I can go to my assets and I can just add. I can just I'll just show you. I'll just remove this. Here what I have, I have my, suppose see if I have Kerala, I can add my boundary Kerala. So my boundary gets Kerala as added from my assets. No, these are my assets which are already stored. Or if you don't have those assets, you can directly search from those global administrative boundaries, and you can just add. So for adding, either this is the way you add it, or suppose say now I have added, or the other way is that you just search from the database. There is FAO, there are already global boundaries are there. So in this case, I have taken the level 2 global administrative unit layers. So variable is stable in this e.feature collection. So I'll be using this level 2 boundary. Then from this, now what I want to do is from this table, I want to, because this is the boundary for entire globe, from that I want to get my boundary at administrative second, administrative second layer. First will be the state layer, and then there will be the district layer. So what I'm trying to do is that I am searching my boundary for Alafuza. So variable I have defined Alafuza from the entire table, whatever it has searched, whatever boundaries. If you see second level boundaries, if you just see over here, you can go to the table schema. It will show you what code it has. It has administrative 2 code. So at second level, so boundaries, these are international boundaries for entire globe. It has boundaries. At this admin 2 code is for second level. So from this boundaries, from the level 2 boundaries, I want to extract the admin 2 name, and that is the Alafuza boundary I have to extract. So this I have extracted. Now once I have extracted the boundary, I want to add. No, I want to see whether my boundary is extracted. So I write map.add layer. So now if I run my command, so now my boundary gets added over here. See, Alafuza, only Alafuza gets added over here. So from the entire global bond database that this boundary had, this had an entire global database. From that, this Alafuza boundary gets added, and it gets added over here. Next, now since I can also zoom. There is an option, you can whatever you have added, you want to get a central. If you don't do it, it will not project to your particular place. It may show you any place, even if the command may run, but it may not highlight the area which you have extracted. So if you add map.center object command and you give the zoom level, so if I run it again, so it will zoom to that particular place where the boundary actually lies, and you can have different zoom levels. You can try with 10, 8, 1, whatever. You can just try with this zooming also. You can also make this boundary as a hollow. You can even make it as a transparent layer. Like I have shown here. See, for Assam boundary, it is a transparent layer. You can make it as a transparent layer. So you need to have your do that also. Next, what we are doing in this particular case is, now we have got the boundary, but now we want the Sentinel-2 data, because we are working with the Sentinel-2 data and we are using an NDWI command, and NDWI command needs green band and the NIR, green and NIR bands of from the data. So import the Sentinel-2 image collection for before floods. First, we will try to have a pre-flood, image. So we are trying to import the Sentinel-2 data for before the floods. Then we'll filter the image collection. Whatever images have been filtered, we will filter the image collection using the filter bounds, and we will use the date to filter. Then we will sort by the cloud cover. So because a number of images may be sorted out, but we want with the images with the less cloud cover or no, then create the mosaic, because this area may be covered by maybe 1 or 2 scenes, probably by 2 or 3 scenes. Suppose it is a bigger area, it may be covered by, or the pass may not be in a single pass, it may be in 2 or 3 passes. So we need to mosaic the entire images. So now what we do? So we have to define the variable. So we have defined the variable image collection, because we are saying it 1, because we have we will have 2 images, one for the pre-flood, one for the after flood. So e.image collection Copernicus S2. So this command, you need not worry. Once you write Sentinel-2 over here, you will get this command automatically. Like for FAO, if I write over here, if I want to have second level, the commands are here. See, e.feature collection level 2, it is given over here already. You can just copy this command, even you need not to write your own command. So similarly, if you write sentinel-2 over here, you may get all, you may get the sentinel-2 data from the Copernicus, and see like sentinel-2 which level you want, level 1C, level 2A. And if you click it over here, you will get the command, you will get the command for it. And then you need to filter bounds. So now what I have done is I have given the image collection of sentinel-2. Now I will filter it for my area, because Alafuza is my area, so I want to filter it for that area only. I want to filter it with the date. So my date is, because I am targeting floods of 2018, so I have, this is the pre-flood, so I have filtered for the month of February. Then I want to sort with the cloud cover. Then I want to use the mosaic images, and finally I want to clip the images, whatever images it has come out. So I want to clip it to my area only. So I'm using dot filter command, dot filter date, dot sort, dot mosaic, dot clip. So all these commands I am using for my before the floods. So these commands will be, if I run, they will run. But since I have not asked them to add into my window, nothing will get added, because I have not used map.add layer. If I don't add my images, nothing gets added to my window, only it runs. But suppose say now if I want to add those, okay, suppose say if I want to add those layers, so I need to define. So suppose say now if I want to add add my image, so I want to, I have to define I define a display the true color. So they have, that command has sorted the images, but I want to display the true color image. So for that I want to, because for true color I use band 8, band 4, and band 3. So I define a variable true color, sentinel-2. I give, you have to define a variable, you can give some name. So I want band 8, band 4, band 3, and I define the minimum and the maximum, with the pixel values over there. And I say map add layer image collection 1. Image collection is 1 is this. True color, I define the variable true color over here, and I give some name. You can give a dry season true color. You can write the pre-flood image or whatever you run, and you run. So now by running, I'll be adding the image for the before the flood. I'll get one image added to my window. So if I run it, so see, it has mosaic, it has clipped, it has sorted with the date, and it has also given me the most cloud free image of my area. So that data gets added over here. So this is the dry season true color here. So this is the command which here you write. I can write it as a pre-flood image also. Whatever you write in the which is in the strings, that you can we can add it. Now because it is a floods, I am interested in the floods. I'll also add my flood image. So same way, whatever I have done in the first part, I also write over here for my for my post flood or the during flood commands. So same way I will import, I will filter, I will sort, I will create the same thing, but I define it as image collection 2 because that was image collection 1. So I define the variable as image collection 2. Same steps I do, and I run. If I run it, it will not get added, because to add again I have to use the command map add layer. So now I before running that, I again ask map dot add layer. So once I run it, so once I run it, now I have both the pre-flood, I have the post-flood image also. So you can just see this is the post-flood, this is the pre-flood. So you can zoom it and you can just see the post image and the pre-event image. Now we will now we'll compute the NDWI, because I have already told you that normalized difference water index is a ratio of the green and the NIR band. So now what we are trying to do is we are trying to compute the we are trying to compute this the ratio of the ratio of the green and the NIR bands. So what we do is that we write variable image collection one, because this is the pre-flood image and this is the flood image. So we add both, we define both variables over here, and we say normalize. Now to do the NDWI computation, you need not do anything. You only need to have image collection dot normalized difference. Automatically, it will do that ratio whatever B3 minus B8 upon B3 plus B8. You need to only define the bands. In this case, our bands are B3 and B8. I just wrote for image collection 1 dot normalized difference B3 B8. For image collection 2, similarly for the second image also, I want to have the B3 and B8 ratio. So I just write normalized dot normalized difference and I run the command. So this command will run, and it will generate the output, but this will not get added since I have not again added those images. But for doing this, even if you are doing your NDVI, so same way you need to write, you need to only give the bands which are concerned for NDVI, and similar process will happen. So now after doing that, I will just add those outputs over here. So what I do now to see whether my outputs are generated or not generated, so I have to just see those, So, but before I generate my outputs, I also need to generate a variable water palette. See, because this is a theme now. Whatever output is, it's a derived layer. It is a thematic output, so it will have some colors. It will have some colors. It is not like a satellite data. It will have its own. It does not. It will not have band, but we need to have colors because it is a ratio image. It will have values from 0.5. It may have a positive value. It may have a negative value. So it may have a range of values. So we need to define a water palette. We say red, yellow, green, blue. So we define a palette for that. It should use these colors, and we say the range of those values will be from minimum -1 to maximum 0.5. So this also you can, using your inspector. If you click it over here, you will go. You will get that value over here. See, you will get the NDWI values. It will show you what are the values ranging from. You can just see those values once you run it over here. So you will get those values. So once you do that, and you again run your layer. So these two outputs also get added into your this mapped display. And now you can see, earlier we were adding the two pre and the flood image. Now we have two images, of the flood and the pre-flood and the flood image. So I'll just show you this. This is the NDWI image of the before the flood, and this is the satellite data for the particular area. So it is taking some time to get displayed. Suppose say here the water body is over here. So now I just display my dry season. Dry season means before the flood actually happens. So what is there? The water bodies that are already existing on the ground. So if I add my layer, so this is my layer. See, if I see this, so these are the pre-flood scenario. So these are the water bodies or the areas with moisture which are already existing into that particular district. Now once I once I have done it, so now I can also see my wet season. After once the area get flooded, what is the scenario? See, this earlier this blue was not there, but now this blue is becoming more prominent because this area have got flooded due to the 2018 rains. These low-lying areas also got flooded. So if I check my data, so and I just See this all blue is the post or during the floods, those areas which have got inundated, so which were not there in the dry season. So NDWI, because it takes a ratio of those two, it easily helps you to delineate the areas which have got flooded or where the water has increased. So if I can simply, and you can even match with your flood image. This is a flood image. If you see, this is the flood image where you can see the what these are all the green colors or the greenish, bluish greenish kind of tinges you are getting is all the flooded water. So you can just see this is a which it has mapped, using which we are able to classify using NDWI. So this kind of output gets generated, and for each time, if you want to see what is happening, or you can just go into the see this, it is showing in each band how this band wise what is happening for the flood image or for the wet image, and this is a ratio. So what is the value coming up before the flood? What is the value 0.23 during the flood? What is the value 0.52? You can click and you can just inspect and see whether what kind of values you are getting. You should get a positive value for the flood areas. It should increase, so it increases. It is 0.20 before the flood, and after the flood water it is becoming 0.52, whereas other areas it may be a negative, or because it is not flooded, so you may have a see it is minus already, but after flooding also it remains in negative. So NDWI means it gives positive values for water, and all other than water it gives a negative value. So you can just inspect those values by clicking here. It is like a in ArcGIS or QGIS, you click with the identifier on the image, and you see the output values on the on the click. Similarly, on the click, you can just see the lat long also, and also you can whatever outputs you are getting, you can just see over here. So it has this has taken the we in this exercise we have taken the ratio of the green and the NIR band. So for you can see right from adding your boundary, right from adding your district boundary or whatever, or the state boundary, you can add it from the global sources. You need not have it in your machine. You can display the data sets. You can also you can also filter the images from the image collection from the Sentinel-2 data. You need not download, or you need not go to the Copernicus site to download, or you need not have a separate login to download your Sentinel-2 images. You only need to tell from which the administrative boundary, for which administrative boundary you need to filter, and for which period you need to filter, and what if you are looking for any cloud cover kind of options you can use, and you need to mosaic it, and then you need to clip it so that you see a specific output which you are interested, and not the other entire over entire area. If you don't give this, it will give you for entire region. If I don't give for clip for Alappuzha, or I don't ask it to filter by bounds, so it will give for entire entire globe, whatever areas it has collected between these two dates. So it will give you the image output for those dates. Once you have filtered, you have clipped, you can display by using command map add layer. But before adding, you need to specify the bands which you want to get the images displayed. You can change the color also. You can change see by changing the combination. If you can change it to 348 also. So this is at your hand. So this gives you a lot of flexibility, even to change your band combinations, which otherwise you will have to do it the other way. But if you do it this way, you can even change your the way you want to see the data. It will change your it can change. See here now it has changed the band combination. If I have changed my band the sequence, so it has changed the color also. Accordingly, it has changed the color. So you can try all those combinations also for your cell. So you need not do anything. So it will do that. And once you want to have the ratio, you need only to specify the variable for which you want to have that ratio, and use a normalized difference command, and specify those bands. And to display, you need to have a water palette. You need to give which colors it should be displayed, so that it takes those colors, red, yellow, green, blue, so that it takes the generates output into those colors. So it will generate, see, blue is for generally blue is coming for the water. So once you have done that operation, you can also, now we are interested to extract the water. Now, since this command has classified the water, but we need to extract the water. So what we do is we use extract command. We give a water threshold. So we will now give a set a threshold to extract all these blue areas. And for setting up the threshold, you need to click on those pixels and see what values, what are the optimal threshold that can be used. So you can see for this case, we, by inspecting all those polygons, or those pixels, not polygons, pixels. So we have seen the values greater than 0.05 are classifying the water areas or the flood areas in a more better manner. So I have given a variable threshold. So, but to see the output, you need to you need to have that use that threshold. So what we have done for both kind of cases, for the pre-flood and the post-flood, we have used variable for the image collection one, and we write dot mask. So we the dot mask command is used. Image collection one, get threshold GT threshold. So for the image collection one, it has to use this particular threshold and run. So we again run this command, but nothing will be added again, because this threshold gets applied to the output. This whatever this classified NDW output, this threshold will gets applied. But before adding, before we want to just see whether this has this particular script has got executed or not. So we will have to use map.add layer. We will map.add layer. So we want to add this image collection one, and for adding also we need to define which color that layer will be we want to display, because we have to use a palette, because it will extract some layer, but because from the threshold, but those particular threshold extracted pixels in which color we want to display. So we will now in this case we have given blue. Then what name we have to give some name to that layer. So you can write water before, or water pre-water, whatever you want. You can just write on this particular strings, and you can run it. So now your output gets added water before. So it just gets added. You can even change it to, if you want, you can change it to pre-flood, or on a pre disaster, whatever you name you want to add. You can just simply adding like print command you use, you can add over here, and that gets displayed into your layer. Now my layer, with the threshold whatever I have given, using this threshold, my output has got generated. So this is the this whatever threshold I have used. This is for my before the event. So this is the pre-event image. So black, whatever you are seeing, dark bluish is the or blackish tinge tone is there. This is the before the event. So my threshold has extracted whatever threshold from those by selecting I had selected. So based upon threshold, it has masked. Those pixels have been masked from the entire whatever NDWI image, and it has given a blue color because I have defined the blue color to the palette, and it has given a name water before because we have specified that particular name. So from the variable image collection one, it has set a threshold of 0.05. Then it has masked that, and then it has it was just added those layers. And for my post second data which I have for the second during the event, same way I already it will use a threshold. You can have a different threshold also for the both images if you want. You can have that, but here I have used the same threshold for the convenience, and I have again run the command. And I run it again. The second output also gets added to the window, and this time if I zoom it here. So this is the dry season image, false color image getting added. This is the flood time image getting added. Now my dry season, pre-flood NDWI classified output is coming, and now after that is post NDWI is coming, and now with the threshold, whatever threshold I had given, so this threshold has identified this is the pre-flood water, and now this is the water that is after the flood has come. So this is the cyan color with the threshold it is extracted. So even if I want to see on top of the other, I can change their sequencing. If I want to see the pre on top, so I can or post on top, I can change their sequence also can be changed. If I want to see water after or before on top, that way also it can be you can visualize the area. If you have any, if you want to see it on the reverse way, I can again run it, and again now my water after gets on top, water before gets on the down. So that way also we can do it, so that for my convenience, if I want to see. So I had added water after. If you know, if you want to see water before on the top, you can add water before on the top, or whatever sequence you want. Like so we can do it that way also. So after adding, there are also, you can also take export this layer as a TIFF file. If you want to, once now you have generated this layer, now you can take it to your QGIS or your GIS layer. So there are commands where you can, export this data as a raster format. Also, you can just export it. So if you see export, it allows you to export as a TIFF file, export.image to .drive. It will take you to Google Drive. You should have space in your drive. So what we want to export is image collection one, that is a pre-flood. So you have to give a description. So we say NDWI raster, and you have to file name, some prefix also. You can give any name. So NDWI raster. Then which region you want. So our area is Alafuza. Then Mac pixel. This is the resolution at what even try with this resolution. That will increase your size or the space of in your drive. So you can you have to be a little careful about this size also. So you just once you run it again, if you go to your task, so this output it will gets added into your output. See, NDWI RAS has come, whatever I have given here, it gets added over here as unsubmitted task. And if I run it, this output will run and get this layer will gets stored into your Google Drive. You can just check it into Google Drive and download from your Google Drive. But this is for image collection one, and I can do it for the flood image also. I can do it for the image, for the second image also. So there are commands to again, once you want to export it, this to this to as a shape file. If you want, you can again export entire thing as a shape file also. Or if you either you can convert into your QGIS, but if you don't want to convert it, if you want to do it over here, it is possible to convert your raster layer into shape file. So again, you have to define the variable that is flooded. In this case, I have given flooded vector, or you can write flood vector or whatever flood shape file. You can give your name. Main thing is that I want to convert image collection one, and I want to reduce it to I want to reduce to vectors from raster. So I use dot reduce to vectors, and you have to define a scale. You have to define a geometry type. This is a polygon in this case, and geometry for Alafuza. And then you have, there is a 8 connected. There are some 8 connected. Whether if you want to disconnect pixels, then you can just and you can export it to again to a Google Drive in the same way we did for your your raster layer in the first case. And if you run it again, this also gets. I have given name NDWI vector. So NDWI vector gets added to my raster was one layer, which will take it as a raster file, and other layer is a vector file, which will take it as a shape file or a polygon file, and you can do the analysis. So once you have, once you run it, you can take it to a drive, and now you have all, you can even take these layers also. And now once you have finally the output, which we are interested, so which we are interested only in the flood layer, those images we need not store in our machines that will that are no off, because we are interested only in the final output from those images, and this output we already now have with us. So, so what we can do is that with this, with this output, we can now we can integrate this we can integrate this particular layer with our land use or our roads. We can integrate that integration. We can do at our machines. If it is not, if it can be tried here, but if you want to do it in that particular part now in your machine, to have that statistics, even statistics can also be done here, but that all will that all will take time. But for those who are interested, can do that statistics part also. Like I'll just show you one script we are running over here. In this case, you can add your own legend. Like legend is getting on the right side. You can give color to here. You can label your output. You can run your results, for which you can even estimate the area by using the pixel size, and the resolution. You can just you can just add your area also, and you can do other type of computations also if you like. But for the moment, this exercise we just wanted to focus to how to extract those flood layers or water spread layer, and then you can take it to your own machine. From this, like here from the task, you can download and you can run this, and it will ask you, where you want to store it. You have to give that in which format you want to take it, KML, KMZ, or where you want to take it, and you need to give it. And in your drive, you need to have that particular space. Or if you have any cloud storage, you can specify the name of the cloud storage you have. Or if you want to put it into the drive, you need to tell the folder, and it will get stored here, and then you can download in your particular machine, and you can do the exercise further on. So this is what was the entire, the idea was to just demonstrate, because this to just tell the potential of, of the G. Now, see, in this case, we have not used any software, we have not downloaded any images, we have not gone to any website, or we have not done any processing of the data on any machines. It is everything is being done on the particular GE platform, and only using your this particular web address of the code earth engine, and you can do all clipping, mosaicing, all the subsetting if you want to do, or the thresholding, or the ratio, or the NDWI or NDWI kind of operations, all can be done here. So even specifying colors, if you want to, all those can be done here, and you can also extract the thresholds, and you can take it to your machine. So with this, I just like to end my talk, and I hope I was able to give you some kind of insight into this particular Google Earth engine, and those who are interested can further explore this particular this G platform, and can have their own kind of further enhancement to this particular exercise also. And with this, I like to stop my lecture. Thank you for your patience listening, and hope to see you somewhere again in similar kind of lectures. Thank you.